Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we are from Group 10 and we are going to present about green concrete. My name is A.WAHAB ISMADI. My metric number is 208259.
My name is HARIVARMAN RAJINIKANTH, metric number 205641.
Hi, my name is AMELIYA binti A.WAHAB. My matrix number is 208075.
Hi, my name is ATIKAH binti AZIZ. My matrix number 206932.
First, what is green concrete? Green concrete is a concrete which uses waste material as at least one of its components. And for this mini project, we use clay brick as our waste material. Next.
Next, what is construction waste? Construction is any substance that are a result of construction work and demolition building. And we want to focus on clay brick waste because it's available in our lab. And by using construction waste, various landfills problem will be reduced, and it is the most efficient solution. It is good quality material by being impenetrable to corrosion, abrasion, peeling, or fading. And the price per gravel use is in normal concrete is a bit higher than the recycled clay brick. Next. Our objective to use concrete waste is to determine the effect of construction and to find the suitability of cost aggregate placement for the current concrete, and we want to create a lightweight concrete, and we want to reduce the cost production as the price in gravel is a bit higher than the recycled waste construction waste, and we want to strengthen our knowledge on properties of lightweight aggregate. Next.
Next is the reason why we choose construction waste. First, it is easy to use and handle. It impenetrable to corrosion, abrasion, peeling, and fading. And as we can say, we use clay brick, which is resistant to a fire, and it's also light and a natural size. A lot of studies show the strength of a standard concrete, which the replacement for only 25%. The slump test, the density, and the concrete strength show an at optimum value for 25% of replacement in our concrete. Next.
All right, now we'll talk a little bit about methodology. First of all, we designed our concrete mix. Moving on, we also had to test out a few things to determine the properties of aggregate. In order to determine this, we did sieve analysis, water absorption test, as well as specificity. All these are basically just calculations based on the data that we've obtained from our lab works. Moving on, properties of the concrete, fresh concrete, we used slump test. And after that, to determine the properties of hardened concrete, a few tests were carried out, namely compressive strength test, flexural strength test, splitting strength test, UPV, as well as our rebound hammer test. All this was conducted in our lab. Moving on, next up will be properties of our construction waste. The first one that we did was the sieve analysis that I mentioned just now. Sieve analysis test is usually done to determine the grading of the coarse aggregate. In our experiment, we used crushed clay bricks. And as you can see, the passing percentage to the sieve increases as the sieve size increases. And according to the BS grading, the size of the graded aggregate in mm is in the range of 5 to 40 mm. Moving on, specific gravity. Specific gravity as a whole is a calculation of quantity of aggregates of the mixed design. It is also important to know the specific gravity as it is closely related to the density. The apparent, the oven dried, as well as the saturated and surface dried specific gravity has been calculated and is on screen now. Moving on, density and water absorption. Well, the apparent density, the oven dried density, as well as the standard saturated and surface dried density has also been calculated, and it is on screen. The water absorption after 24 hours of immersion is 25.33%, which is fairly high. This is due to the proportion of the crushed clay bricks having capillary pores, which leads to high porosity, and high porosity is where the water molecules will seep in. Moving on.
Okay, next is a slump test. Next is a slump test. Slump test is to determine the workability of a fresh concrete. This slump test is conducted automatically after the mixing of the concrete. As we can see, our construction waste for slump obtained is more higher than our control concrete. This is due to our construction waste has a higher workability, and it is more high workability and low in the strength, which is different from our control concrete. Next.
For compressive strength, it is important to determine the strength of concrete and the maximum load it can withstand. And the strength, as you can see, the strength increases as the age of curing increases. And average compressive strength for used clay brick is lower than control concrete. And this is supported by Dr. M. Patalaju in his article. Next.
Next is splitting tensile strength and flexural strength test. Splitting tensile strength is to determine the tensile strength of a concrete. As we can see, this is our result for our construction waste and our control concrete. We can see the average tensile strength for our construction waste is lower than our control concrete. This is due to our construction waste is low, and this is the difference is just between 5 to 10% of the average tensile splitting test. Next is flexural strength test. This is test, which is can determine the flexural strength of our concrete. As we can see, there's a different average flexural strength for our construction waste. Is more lower than our control concrete, but the percentage of decrease is just around 3%. So it's still acceptable for our concrete. Next.
Next, I will explain about UPV. UPV is used to check the quality of concrete, also defects. And as you can see here, the compressive strength of the construction waste concrete was decreased about 11% from our control concrete. This is due to the low density of construction waste concrete. And we move to the rebound hammer test. Rebound hammer test is used to find hardness and soundness of the surface of the concrete. And as you can see, the compressive strength of construction waste concrete was increased about 88% from our control concrete. This is because higher compressive strength because it has more compacted surface and has less void. And construction waste concrete has better quality than the control concrete. Next.
Okay, next, this is honeycombs that have at our concrete. As we all know, honeycomb is the rough pitted surface or void in concrete. As we can see at the picture, there's some void or surface void at the surface. This is caused due to improper compacting or incomplete filling of the concrete. It will create a gap or void in the between concrete and the aggregate, as we can see at the picture. This is also due to we use a larger of size of aggregate in excessive amount, and the concrete is poured from more than the allowable height.
Okay, let me wrap up. In conclusion, the replacement of construction waste in our concrete is a kind of good replacement. Although it has not achieved the lightweight concrete properties, and although the strength of concrete has decreased in comparison to the control concrete, and as well as the water absorption rate is also higher. And despite all this, the differences compared to control concrete is not as much. And we also have to keep in mind of the cost. This waste material comes at a fairly reasonable cost, and these are recyclable aggregate, and it is good to the environment and it saves the world as a whole. And that is it from us from Group 10. Thank you very much.